we calculate the discriminant to find out how many real solutions we have with a quadratic equation. So discriminant equals b squared minus 4ac. Once you calculate that, if the answer is greater than 0, which means a positive number, then you have two real solutions. Means you have a parabola that hits the x-axis twice. And if the discriminant is less than 0, that means you have no real solution. So your parabola is either above or below the x-axis and opening in the opposite direction, which means it's never hitting the x-axis. Also, the discriminant equals 0, then you have a parabola, kind of parabola where you're hitting the x-axis and you're bouncing off. We call it one solution. So that is if the discriminant is 0. Okay, so based on that, kx squared plus x plus k, find the k value that this equation will have two real solutions. So you go ahead and do the discriminant, which is b squared minus 4ac. So here, b squared minus 4ac, to have two real solutions, it has to be greater than 0. So we're trying to find out what k values could we have that we guarantee that this parabola will have two real solutions, and that's what you're trying to find right here. Sub in your a, b, c, and you remember this is a, b is 1, c is k. So b squared, which is 1 squared, minus 4a, which is k, and c is k, greater than or equal to 0. That gives you 1 minus 4k squared is greater than 0. Now this is a quadratic that what you want to do, you want to factor it. So when you factor it, it gives you 1 minus 2k, 1 plus 2k, greater than 0. Now your k value here will be negative 1/2. That would make this 0. And you could equate this to 0, solve it, and k will give you negative 1/2. And for this one, it'll give you positive 1/2. Now what you want to do, you want to draw a number line, put your negative half, let's say here, and the 1/2 is right there, and find out what k has to be to so that you could have two real solutions. So what you want to do, you want to go ahead and test numbers in all three regions here. You have this region, and this region, and therefore test the number. So if I'm gonna test, the easiest to test is between negative 1/2 and 1/2 is 0. When you sub in 0 here, you get 1. Is 1 greater than 0? Yes, it's true, so you shade there. Another number that we could test is negative 1, which is on this side of the negative 1/2. So if I put negative 1 there, that becomes 1 when you square it, and then 4 times 1 is 4. 1 minus 4 is negative 3. Negative 3 is greater than 0. No, you don't shade there. And if you sub in, let's say here 2 or 3 or even 1, if you sub in 1, you get negative 3 again. It's not greater than 0. You don't shade there. So the k value has to be between any number between negative 1/2 and 1/2 to guarantee that you're going to have two real solutions. Okay, let's move on to number 2. We want no real solution. So we want this parabola where, you know, you don't hit the x-axis at all. So it could be above the x-axis like that, or below the x-axis like that, where it'll never hit the x-axis. So therefore, k b squared, which is negative k squared minus 4 times a times c, a is 1 and c is 1, equals 0. Sorry, that has to be less than 0 if it's no real solution. So that's k squared minus 4 is less than 0. Again, in this situation here, we have to factor. So k minus 2, k plus 2 is less than 0. Do your number line. Your zeros here that will make this 0 and make this 0 is k equals 2 and negative 2. So I'm going to put negative 2 there and 2 there. And I'm going to test. So I'm going to put in this equation right here, I'm going to put 0. I get negative 4 is less than 0. That's true. So you shade there. If I put in, let's say, 1, hold on a second. Sorry, if I put in, yeah, I put in 0 there, it doesn't work. So if I go into this region right here, I could use 3, 4, 5. So I'm going to use 3. If I sub in 3 there, 3 squared is 9, minus 4 is 5. That's definitely not greater than 0. So you don't shade there. And if I put, let's say, -3 and -4, let's try -4. -4 squared is going to be a positive 16, minus 4 is 12. Is that less than 0? No. So you don't shade there. So for this solution also, K has to be between -2 and 2. So any number you put in between -2 and 2 for K here, like you put 1, you put 0, you put whatever, between -2 and 2, and you sub it into here. If you graph your parabola, you're not going to touch the x-axis. Okay. How about here? It's the question, I think, in this one, they want to have one real solution. So I'm just going to finish writing the question. So for this to have one real solution. Well, if it's one real solution, then what we have to do is make sure negative b, which is negative k squared, sorry, b squared, which is negative k squared, minus 4 times a, which is 3, times c, which is k, has to equal 0. Square this, you're going to get k squared. This will give you minus 12k. And because one real solution, it has to equal 0. The discriminant has to equal 0 to have one real solution, which means the graph is hitting the x-axis once. This you get a factor, k and k minus 12 equals 0. So therefore, k has to be 0 or 12 to have one real solution. There's no inequality sign here, so you don't have to do any testing. These are your answers. So for this equation, to have one solution, you have to make k equal 0, or you have to make it equal 12. And that's it for discriminants and the nature of roots. Till next time, thanks for watching.